You know how you're always searching for that faster way to get up to speed on something complex? That quick insight, especially with tech stuff changing so fast. Well, what if you could get deep insights, like instantly? Today, we're diving into something that promises pretty much exactly that for a really key area in AI. We're looking at a really interesting report from Inception Labs. It's about their new language models called Mercury, and specifically how they're using them for coding.
Right. And our mission here really is to unpack what makes Mercury tick, what makes it different. We'll get into the core tech. It's all about diffusion models, but for language.
Hmm.
And then, what's the immediate impact, especially for coding? Because this isn't just a small step up, we think. It feels like a pretty significant shift in that whole speed versus quality game for LLMs.
Okay, let's dig into this. We hear so much about large language models, right? But this Mercury thing, it's doing something novel, using diffusion for text.
Yeah, exactly. And what's really fascinating is how they're taking diffusion models, the ones that are just amazing for images, for generating video.
Mhm. Right, the state of the art for that kind of media generation. Yeah.
Totally. And applying that whole idea to language. So instead of building text one token at a time, like the way most models work,
The standard autoregressive approach? Yeah.
right? Mercury actually generates multiple tokens all at once in parallel.
Mhm.
It sort of refines the whole output together,
Hmm.
starting from like random noise and shaping it up. It's a fundamentally different way of getting to the final text.
Huh. So it's less like typing out a sentence word by word and more like maybe sculpting. You rough out the whole shape first, then add details everywhere at once.
That's a great way to put it,
Yeah.
actually. Yeah, precisely. And that parallel generation, doing lots at once, that's the key to why it's so much faster. It just uses the hardware, the GPUs, way more efficiently.
And here's the part I found really interesting. Even though the generation method is totally new, under the hood, it's still using that familiar transformer architecture.
Yeah, and that's super important.
Why does that matter so much?
Well, it means they can tap into like years of optimization work that's gone into training and running standard LLMs really efficiently at scale. So from an integration standpoint, you could almost just drop Mercury in where you had an older model.
Like a drop-in replacement.
Kind of, yeah, but with this huge boost in inference speed. Plus, they can use all the standard techniques for instruction tuning and making the model safe and helpful. It's not starting completely from scratch.
Got it. Okay, so Inception Labs decided to point these first Mercury models specifically at coding. Why start there? Seems like lots of areas could use faster text generation.
That's true, but coding is intensely sensitive to latency. I mean, think about using a coding assistant.
Right, autocomplete.
Exactly. Autocomplete, code edits, or even these more complex agent tasks where the AI does a multi-step job. If there's lag, it breaks your flow. It's really disruptive for developers.
Okay, so user experience is paramount.
Hugely. And the report mentions over 84% of developers already use code LLMs. So there's a massive user base ready for something faster and better. Focusing on coding gives immediate, measurable impact.
And they launched two versions, right?
Yeah.
Mercury Coder Mini and Small. And the speeds they're claiming are, well, they seem pretty wild.
They are pretty staggering, yeah. On the latest NVIDIA H100 GPUs, so top-tier hard Margaret the Mini hits, 1,109 tokens per second. The Small does 737.
1,000 tokens a second.
Yeah. And the report points out that kind of speed, until now, you basically needed custom-built chips, like ASICs, to even get close.
Wow.
So connecting this to the bigger picture,
Yeah.
it's not just about making developers happier, though that's huge. It could seriously bring down the cost of running these models at scale. Makes powerful AI potentially much more affordable.
Okay, big claims on speed. But how do they actually stack up against other models out there? Do they get independent checks?
They did. The report includes evaluations from artificial analysis, which is independent, and also human preference tests on Copilot Arena, so real-world feedback. And they benchmarked against a ton of stuff. You've got your open-weight models optimized for speed, Llama 3.18b, DeepSeek Coder V2 Lite, that kind of thing.
Hmm.
Then closed-weight ones also focused on speed, like GPT-4o Mini, Claude 3.5 Haiku, Gemini 2.0 Flash, Codestrel.
A lot of familiar names there.
Right, and they even compared against giants like the full GPT-4o, just for context. But Mercury's main target is really hitting that sweet spot among the speed-optimized models, better performance at high speed.
So boiling all that down, what does it mean for, say, a developer using these tools? What's the practical takeaway from the benchmarks?
Well, the result's pretty striking. Mercury Coder Mini apparently outperforms all the open-weight competitors they tested while being over 8 times faster, hitting that, 1,100 tokens per second mark,
8 times faster and performs better.
according to their benchmarks, yeah.
Mm.
Then the slightly larger Mercury Coder Small, it performs about on par with some top closed-source speed models, like Haiku or Gemini Flash.
Mhm.
But again, it's way faster, like 3 to 10 times the throughput.
So they're really pushing that boundary, that trade-off between how good it is and how fast it runs, getting both.
Exactly. Pushing the Pareto frontier, as they say. Getting top-tier quality at top-tier speed, which is really the goal for these kinds of applications.
Does it perform well across different programming languages? Or maybe specific tasks like that autocomplete you mentioned?
Yeah, they looked at that. On a benchmark called multi-PLE, which tests languages like C++, JavaScript, PHP, even Bash.
Mhm.
Both Mercury models held their own against the established speed models. They look particularly strong in Java and JavaScript, actually.
Okay.
But where they really shone, apparently, was on fill-in-the-middle tasks.
Yeah.
FIFIM, they call it.
Mhm.
That's absolutely critical for good autocomplete, right? Predicting code inside a line you're typing.
Right, makes sense. That's harder than just predicting the next word.
Much harder. And here, both Mercury Mini and Small achieved state-of-the-art results, beating all the other models they tested, even specialized ones like CodeStroll.
Wow. Okay, benchmarks look good. But what about that real-world feel? The Copilot Arena results.
Right, because that's actual developers choosing which code suggestion they prefer, blind. And the results there were fascinating. Mercury Coder Mini tied for second place in quality.
Second place. Against which models?
Against everything on the platform. It even beat out much larger models like GPT-4 on some user preferences.
Yeah.
But here's the kicker.
Uh-huh.
It was the fastest model overall on Copilot Arena. Average latency was just 25 milliseconds.
25 milliseconds. That's
Right.
instant, basically.
Pretty much. For comparison, they said that's about 4 times faster than GPT-4 Mini on the same platform.
Oh,
So it really validates the speed claims in a real-world setting. It makes the AI feel invisible, seamless.
Okay, that's undeniably impressive for coding. But stepping back, what does this mean for AI more broadly? Is this diffusion for text thing likely to spill over into other areas? It feels like it could be a really big deal.
I think it absolutely could be.
Yeah.
This work feels like a significant step towards AI that's just more efficient, easier to scale, maybe even more controllable. The implications go way beyond just code.
Like what?
Well, think about any application where you need high-quality text generated fast. Creative writing tools, real-time data summaries, maybe even just better, faster chatbots that feel more natural because there's zero lag. And the report mentions the context length, too. They handle almost 33,000 tokens out of the box, and potentially up to 128K with some extensions, so they can handle really long documents or complex coding projects.
Yeah.
That versatility is key.
And is there potential to make these diffusion models even bigger and better? Does the performance scale up? It seems like it. The report clearly shows the larger small model performing better than the mini across the board. That's a really positive sign. It suggests that as they scale these diffusion LLMs up further, we could see even bigger gains in capability without necessarily sacrificing that incredible speed advantage. It hints that maybe speed and quality don't have to be such a harsh trade-off going forward.
What an incredible deep dive. It really feels like Inception Labs Mercury models, especially these coder versions, are changing the game for speed and quality. A genuine leap, making AI assistants feel so much more responsive.
Absolutely. And if you think bigger picture, this whole idea of parallel generation, refining content iteratively, it's not just about code completion becoming instant. It really makes you wonder, doesn't it, what other areas that are super sensitive to latency could be totally transformed by this.
Imagine, I don't know, instant draft generation for writers, or real-time analysis popping up as data streams in. Maybe even conversational AI that just feels completely natural, no awkward pauses. It prompts the question, really, what do you see as the next big frontier for AI that needs to be both ultra-fast or really high quality? Where could this tech make the biggest difference next?